Another example here. Okay, this time, what are we trying to do here? We're trying to make a rain gutter, right? So we make rain gutters out of sheets of aluminum, long rectangular sheets of aluminum, and then we just bend up the edges to make a trough. That's all we do, right? So we start off with these long sheets of aluminum that are 18 inches wide. And so if we want to give this thing a little perspective, it just looks like this, right? Right, so if I want to give this thing a little perspective, like there's the front edge, and I've got this long sheet. That's kind of disappearing into the distance, right? Here's the front edge, and if, let's say this thing has some lines on it, the lines are just going to look kind of like that, right? It's just going to go. Everybody get that? There's my perspective drawing. So this is the front edge, and that's the back edge a long ways away. Okay, what I'm going to do, everybody see what that looks like? Just my not very good example of a perspective drawing. Okay. So now I'm just going to bend the edges of this long piece of aluminum up to create a trough that the water can flow through, right? And so let's label this. We don't know, we're trying to figure out how far do I bend up the edges to transport the most water, right? Well, it turns out, and this makes sense, doesn't it, that I just want to create the biggest possible cross-sectional area there. I want the rectangle that's going to represent the water flowing down this thing when it's totally full of water. I want to have the biggest area possible of water that's flowing down this trough. Everybody agree? When we say something like a cross-section, you know what that means? What's like if I took the cross-section of the trunk of a tree, what shape would it be? If I look at the cross-section of the trunk of a tree, yeah, it'd be a circle, wouldn't it? Right? In other words, if I cut through the trunk of a tree, what does the cut look like? It'd be a circular cut, wouldn't it? Right? So here, we're going to bend up the sides. So if I've got water flowing down this, I've got water flowing down through this trough, the water is going to make a rectangular shape, right? I've got this, like pretend I froze the water into a block of ice and I cut through the ice. Well, wouldn't I just get a rectangular cross section to the water in the gutter then? Okay. We want the area, we know that we can transport the most water, the largest volume of water through our trough if that cross-sectional area is the biggest it could possibly be, right? Okay, so we don't know what the depth of the gutter should be. That's what we're trying to find. So we're going to call that X, right? The height of this thing is going to be X, or the depth of the trough, let's say, is going to be X. Okay, and if I draw a picture of this again, here's kind of what my trough looks like then. I've got this. Everybody agree that's my trough when receding into the distance. Okay, so I need to know though, I want to be able to calculate the area of this cross section. Well, just like before, you already told me that the area of a rectangle is just length times width, or in this case, depth times width, right? This cross section of the gutter, the area of the cross section is going to be the depth of the gutter times the width of the gutter. Well, what's the width of the gutter going to be? If we built this thing by bending up the edges of an 18-inch wide piece of aluminum, type in chat for me, how could I write down the width of this gutter then? What's the width of the gutter going to be? the width of the piece of aluminum that we used to bend the gutter was 18 inches. So what's the width of the gutter going to be after I make those bends to create the trough? What do you think? Still waiting for some answers. We said that the depth we were going to call x. That's an unknown, so we have to call it a variable, right? Because we don't know what the value of the depth is yet. Because I want to calculate area here, right? So my area is going to be x times what? I need the depth times the width. I got to know what to multiply x by. Okay, we're getting there. We're getting there. So it's like I'm going to put my bends. Let's say that this distance right here, if that's x, I'm going to crease the thing right there, and I'm going to fold that part up. And I'm also going to have to do the same thing on this side, aren't I? If that distance is x, I'm going to have to bend this side up by x also. So there's my crease. And I'm going to bend that side up, and I'm going to bend that side up. So what's left on the bottom then? Some people said 18 minus x. Is that right? What if x happens to be like 4, for example? Let's just say hypothetically that we want the depth to be 4 inches. If I bend each of these tabs up to be 4, what's the width going to be? Is it going to be 14? 18 minus 4? Right? Let's just say I created a gutter. This may not be the right one, but if that's 4 inches and that's 4 inches, how wide would the gutter be? Type it in for me, please. It'd be 10, wouldn't it? Yeah. Right? Because the whole thing has to add up to 18, right? Well, I don't know that it's 4. I called it x. So what's that width going to have to be? Okay. I see a correct answer up there. Can anybody identify what it is in the chat? There we go. Yeah, it's 18 minus 2x, isn't it? Because I've got to subtract that x and that x from my total of 18. Okay, good. So then I know that my area is going to be x times 18 minus 2x. That's my cross-sectional area, isn't it? Now look, I've only got one kind of input, x. So I could call that function a of x if I want to, right? Because I'm inputting x's. That's the only thing I need to input to make my calculation of my output area, right? And this looks an awful lot like the last example we did. If I distribute that x, would everybody agree? If I distribute, I'm going to get 18x minus 2x squared, and I can rewrite that to make it look like a quadratic function in standard form. If I just put the x squared term first, now that looks like ax squared plus bx plus c, doesn't it? Right? So what are the values then? You tell me. What are the values here for this function? Type it in chat, please. What are the values of, let's not confuse the a's. This is our little a, right? Not our capital A for area, but just our regular old little a for standard form. What are the values of A, B, and C? Type those in chat for me, please. Okay, good. Yeah, so we get -2 for A, that's the coefficient of x squared. We get 18 for B, that's the coefficient of x, and there is no constant, so C is equal to 0. Okay, so if I've got A, B, and C, I should be able to calculate the coordinates of the vertex pretty easily, right? We know the formula. H equals -B over 2A. So what's that going to give me? If I plug in, if B is 18, then -B is -18 divided by 2 times A is -2. 2 times -2 is -4. Negative over negative is positive. And if I divide 18 divided by 4, I'm just going to get 4.5, right? That reduces to 9/2. We'll just write it as a decimal. That's just 4.5 is my value of H, right? Okay, so that's useful. If I were going to make a graph, or think of this in terms of a graph, so X is my input, that's my horizontal variable. The input is always the horizontal variable, and my Y value in this case, well, Y, we're replacing with A of X. That's my output. So that's area. Well, I know one thing. I know that my X coordinate of the vertex is going to fall halfway between 4 and 5, so 4.5 inches. If I want to calculate the output, I'm just going to plug 4.5 into my function. And let's use Desmos for that, right? We can use Desmos to make that calculation. So remember how we use Desmos here. I'm going to type in, and I shouldn't say F, I should say A, shouldn't I? Whoops. Not that it makes that big of a difference. But my function is A of X, not F of X, right? So let's make that one little change. So K is going to be A of H, which is 4.5, okay? So in Desmos, I'm just going to define my function, first of all, right? So I've got A of X. Remember this trick? This is so useful. A of X equals -2x squared plus 18x. And then I'll just go down to the next row and I'll evaluate my function at 4.5. Look what I get, 40.5 for my answer. And you have access to Desmos, the scientific Desmos, and that's all I'm using. It's not even the graphing one. You have access to that all the time on tests, right? So you can use Desmos for this stuff. Oops, right there, that's what I want. So A of 4.5, we already found the value of K then. It's equal to 40.5. And so let's say I'm going to change the scale on this. We'll go up by tens. There's 10, 20, 30, 40, 50. So I've got my vertex at 4.5, 40.5, so right up about there. Does this parabola open up or down? Give me a U or a D in chat, please. Should hear from everybody. Okay, yeah, A is negative, so you know it opens down. So we got it, right? We got it. We know. We're trying to find a maximum for volume, right? Well, maximum for cross-sectional area, so we can maximize the water flow, right? And so what does this tell us then? What do the coordinates of the vertex tell us? Well, the 4.5 tells us that the depth equals 4.5 inches, right? And the 40.5 is telling us that the cross-sectional area equals 40.5 square inches. We don't really care about that, though. The question didn't ask for that. It just wanted to know what's going to be the depth of the gutter that's going to maximize the cross-sectional area. So there it is. It's 4.5. We got it, right? It's just going to be the x coordinate of that vertex. That's pretty cool. How else are you going to do that problem, right? I mean, I guess you could argue maybe you could go down and make a table in Desmos, but if I make a table in Desmos, look what happens. It doesn't even work this time very well. So here's my table in Desmos, right? I got to change my function this time. So this time it's negative 2x squared plus 18x. Oh, that's going to take forever. If I recreate, oh, there we go, good. So look, I could make my table and I could, oh, look what happened. When I make my table, I didn't get a single value that gave me a maximum, right? And how do I know that every time that my maximum is going to work out to be something convenient? It might be some bizarre decimal that's not going to, that's I'm not going to find using my table, right? So the table is useful sometimes, but really, I mean, if I didn't, in this case, it might not be much use at all. I guess I could reason that because those are even, I get the same outputs at 4 and 5, I could average the two. You could maybe think of it that way. But it's easier just to find the vertex directly, right? I know I've got this downward opening parabola. Just find the coordinates of the vertex, and that represents a maximum because my parabola opens down, right? And the only reason that works in this case is because the function that we built for area happens to be a quadratic function in standard form. If it had been a different kind of function, then we would have had to approach this problem differently, and we'd need a little bit of different math for it. But we're talking about quadratic functions. And so in this case, we ended up getting an area function that's quadratic, and so we know how to deal with it, okay? And it's, I know it's easy to get lost in just the fact that this is just another word problem on an assignment, but try to think beyond that a little bit and just try to see the beauty in that. That's pretty cool that we can take this abstract math concept that seems to have nothing to do with reality, and we can recognize that there's a parallel there, right? It's for some reason the math gods chose to represent this cross-sectional area with a quadratic function, right? And so we can use that fact to our advantage. Okay, everybody give me a 1 to 5 on this process. Is it getting a little better? Okay. All right. I'm going to make this. I want to give you guys a little bit of chance to work here, and we're running. Oh man, we're running out of time. I just want to show you something really quick. I'm going to make this super quick because I didn't mean for this one to go so long today. What if they give us a function like this, where this is a cost function? They're telling us the cost in millions of dollars for a company to manufacture X thousand automobiles. So they're defining what this function means. X is our input, and X represents the number of thousands of cars that your company is building. C is the output, and that represents the cost of manufacturing in millions of dollars. We want to find the number of automobiles that must be produced to minimize the cost. Well, would everybody agree here this is a quadratic function in standard form, and A is positive? So everybody see that this parabola is going to open up, isn't it? This is a quadratic function, so the graph is a parabola. And because it opens up, the vertex is going to be a minimum value, which is what we're looking for, right? We want the minimum cost. So all we'd have to do, and let's just cheat and use Desmos on this one to make it quick. I mean, we could go about this doing the, calculating H and K like we've done in the last couple examples. But let's say that this time we have Desmos Graphing available. Okay, so let's graph this thing. We have C of x is equal to 4x squared minus 24x plus 72. Okay, and I can, if I just zoom out a little bit from my home screen, I can see, I'm not going to make this parabola look really good here. I can see that it is a parabola that opens up, and I can see the coordinates of the vertex are 336, right? That tells me everything I need to know, doesn't it? What does that 336 tell me? It says find the number of automobiles that must be produced to minimize the cost. What's my answer going to be? Blank cars minimizes costs for my company. Type your answer in chat. How many? Type your answer in chat. How many cars? You're the CEO of this car company. You got to make a decision here. How many cars should you target to build if you want to minimize costs, which is important? There's a graph of our cost function. Okay, when I make my graph here, you just got to always think in terms of the graph. If I'm graphing this thing, what do the axes represent? What's my input for my C function? What's the input? What variable is the input variable? Type it in chat. What's the input variable? Here's my function right here, right? Or right here. What's my input variable? Is it X or C? It's X, isn't it? Good. So X is my input, right? So this is the x-axis. The horizontal is the x-axis, horizontal axis. My output is C, and so the output is the vertical axis. My y-axis is charting total cost, right? So A is positive, so I know that this function is going to open up, which it does. And if I look at the coordinates of the vertex, what's the 3 telling me? It's telling me that 3,000 cars, right? Because we're talking about X is thousands of automobiles. So it's telling me that 3,000 cars minimizes cost. And what is my cost? My minimum cost is $36 million. So the answer actually isn't 36. The answer is 3,000. They wanted to know how many cars should we produce to minimize costs. They never actually asked us what the minimum costs were. They just wanted to know how many cars should we build? 3,000, right? Because that's the input value. That's the value of H, the X coordinate of the vertex. Everybody get that? Okay. All right. Well, you got no time to work today. Sorry about that. I'll try to work in some time. Maybe next time. Next time I'll work in some work time for you. Okay. All right. Have a great day. I'll be here after school if you need any assistance with anything, but this should get you going. Really, all this was about the last two questions on 3.4. Okay, so just wrap up 3.4, and next time we'll cover 3.5, and then I'll put a review assignment up, so it'll be next week we'll be doing our test. Okay, I'll let you get out of here early. Have a great day.